Okay, good morning, class. Okay, let's move forward with another component of chapter 5. We're dealing with section of method of sections. Okay, so this is chapter 5, and I believe in your textbook, this section starts. Um, this section starts from page 239. Okay, so the idea about method of sections is um, you are trying to just find or analyze, I should say, certain members within a frame. So you have this total frame here, right? And whether you're trying to analyze whether each member is in tension or a compression, you just want to look at just certain members of this whole structure. So the idea is to use the method of sections, okay? So here's an example. This is a continuation of our example problem that we did in the previous video. But here is a example problem just outlining or reinforcing what we learned in the example problem. Okay, so this particular problem is asked us to determine the forces and members EI and JI of the truss below, right, that serves to support the deck of a bridge. Okay, now they're asking us to state if these members are in tension or in compression. Again, the bigger picture is you need to understand what members are going to be in tension or compression because you want to be able to choose a right material that can withstand the load that this particular deck or a bridge will undergo. Okay, so that's the big picture. So of course, as we start off, we want to draw a free body diagram as step one. Okay, now I just redrew this here. Okay, and again at point A, we have a pin, and at point G, we have a roller. Okay, so a pin has two forces acting on it. A roller, only one force is acting on it. Okay, that's very important. Okay, so our next step typically is to just calculate our support reactions. Okay, so we are, and note, I just put a note here that 1,000, rather than me keep writing 1,000 or 4,000 pounds, 8,000 pounds, 1,000 pound equals one kip, or I can write it as 1 with a superscript of K. It just means the same thing. Then KIP, a kip, just means a kilopound. That's all it means. Okay, so 1,000 pounds is 1 kilopound. Okay, and it's abbreviated as 1 kip. Okay, so if we take the moment about point A, right, um, and this is my point of interest here. It's my point of interest right here, point A. I'm taking the moment about that point, and the first force I come in contact with is, as I look from left to right, is 4,000 pounds, and it is 9 feet away. It's going to create a moment in a positive. That's why I have a 4,000 times 9 feet here. Then the next force I see, it's 8,000 pounds, and that is 18 feet away from our point of interest, point A, is going to create a positive moment. And then the next force I see is going to be 5,000 pounds, which happens to be 45 feet away, and that's also going to create a positive moment. Then my GY, which is my support reaction at Y, it's going to be 54 feet away from my point of interest at A, and it's going to create a negative moment. Okay, so when you do the math, this is typically what you're going to get for your support reaction at G, point G. Now, if I use another equilibrium equation, some of the forces in X direction, I can look at this structure here and say there's only one force going in X direction, and that's AX, and that equals 0, as you can see. Then I want to find what is my force at AY. So what I can do now, I can do a few things, but I just did the sum of the moments about point G. This is now my point of interest right here. And take the moments about that point, and I'm taking clockwise. Any moment in the clockwise position will be positive. Okay, so again, I start from here. I work from right to left. The first force I come in contact with is 5,000 pounds, and that is 9 feet away from the point of interest. So that's going to give me a negative moment, as you can see here. Then the next one is 8,000 pounds, and that's going to be 36 feet away, and that's also going to give me a negative moment. And then the next force from point G is 4,000 pounds, and that's 45 feet away, also going to give me a negative moment. And then my AY, which is 54 feet away from um, point G, that's going to give me a positive moment here. So just solve for AY, and this is typically what you're going to get. Okay. Now, my next step now is I want to be able to make a sectional cut. Okay. So I found all my support reactions, AX, AY, and GY. Okay. Now, I want to make a sectional cut. They want to know is member um, EI, I'm sorry, member EI. They want to know if member EI is intentional compression and member JI is that also in um, tension or in compression. Let me use a different color. This is the member here, this member right here. Okay, so to do that, you just create a sectional cut as I've done here. It's cutting through those two members that are of interest to you. Okay, and then when you do that, all you now do is now separate them, right? And since this to my right is closer to a support reaction, I just chose the right hand side to keep that side valid. And then what's on the actual left hand side, this part we don't need. It's in dots here. We don't need that part, but I'm just simulating. That's how the rest of the structure will look. So really, I'm just focusing on this sectional cut right here. Okay. And again, all the forces from your joints should be positive in tension. Okay. They're moving away from the joint. Okay. Now, when we do that, our next step really now is very simple. We want to be able to find is this member here, the force in IJ and the force in EI is an intentional compression. That's all they're asking. So in this case, all I'm going to do is just take the moments about point E equals 0. This is my point of interest right here. And now when I do that, I know that my EI is going to that point E, so that can't be considered. So I'm going to look at um, force IJ. Okay, so my force IJ happens to be 12 feet away, and it's going to give me a positive moment when it comes in contact with the arm, excuse me. And then I have my GY. I found my GY, my support reaction. GY happened to be 7.5 kips. Okay, so and that's going to be from point E. That is going to be what? 18 feet away, right? And that's going to give me a negative 18 feet. Okay, and then we have this 5,000 pounds here, which is 9 feet away from point E, okay, because it's 9 feet away right here. So, and that's going to give us a positive 5 kips times 9 feet, okay, and that equals 0. Okay, so those are all the forces and their distance as it relates to point E. So now I can just solve for force IJ. Okay, and when you do that, you're going to get 7.5. Okay, and that's going to be in tension. Okay, now I can do some of the forces in the y direction. Okay, this is another equilibrium equation that I'm using. Okay, and when I do that, I know that some of the forces in what are the forces in the y direction. Okay, so I have here force EI, which is what I have right here. Okay, I have another force coming down, 5,000 kips. And I have my GY, which is going up, plus 7.5 kips. And when you do the math, you're going to get force EI, force EI equals 2.5 kips. And that's your answer. And this, I'm sorry, negative. And that's going to be in compression. So in essence, it's going to be written like this. Okay? And this is going to be your answer here. They're both your answers, but this is the more acceptable one. Okay? Here's your answer here. So the takeaway for this particular series, in terms of your method of sections, is you're just trying to isolate the members that you're interested in, and that's why you create a sectional cut. Okay, and when you do so, you're just evaluating those members that of interest to you. Okay, so I hope this helps. Again, you can still use method of joints to solve this problem, but it would take a long time trying to evaluate every single member on this particular um, structure. So when you do a sectional cut, you're just isolating the member that you're interested in. You evaluate them using your equilibrium equations, and then you'll get your answer. Okay, I hope this helps. Thank you very much. I appreciate your time. Thank you.